Hello students, so let's try to solve one more problem from IIT JAM 2023, and this problem from mechanics, and this is from collision, and this is very nice problem. Actually, full of concept is involved there. Calculation is very simple. So there is one particle P1, another particle is P2, and the particle P1 is moving with velocity v. This is given, and it is just going to collide with particle P2, and P2 is rest. Initially, it is at rest before the collision, and both have same mass. And after the collision, the particle P1 is making 30 degree with the line of action. So we can say this is my x-axis, which is line of action. And we have to just judge what will be this angle actually. So there is one, and this is MSQ type problem. So more than one options are correct. So the first option, we have to analyze what will be this angle, how we will going to calculate this angle. So when the both mass will remain same, and one mass will remain rest and another is moving with some velocity, then the relative angle is always 90 degrees. So this option is always correct. So relative angle will be 90 degree. So we have to, the relative angle will 90 degree. And this is actually theorem of this elastic collision. So you can find it in any book, good book. And this is also discussed in our basically study material also. So first we have to just check this option. Second one theoretical thing is that it is also said that the center of mass is after the collision will decrease. No, it is not going to happen, because hence your momentum is going to conserve. There is not any external force. So the momentum of center of mass before collision will remain momentum of center of mass after collision. So this option is wrong. So we have just checked two options. Now what we have to do? We have to just find the speed of P1 particle, and then we have to find the speed of P2 particle, and then we have to find the kinetic energy of P2 particle, and we have to compare whether this kinetic energy is 25% or not. So obviously we have to just go for conservation of momentum. So I have just taken this one in my x-axis, and this is my line of action. So we have mv plus 0 is equal to mv1 cos 30 degree plus mv2 cos 60 degree. So from here we have one equation, v is equal to v1, that is cos 30 is root 3 by 2, plus v2 cos 60 is half. So this is my first option. And second one is we have to just go for basically conservation into y direction. So for y direction, 0 is initial momentum, and we can take this one is positive, this one is negative. There is not any problem. So we have mv1 sine 30 plus mv2 sine 60. So from here, we can say v1 into half is equal to v2 into root 3 by 2. So from here, we can easily say v2 is equal to v1 by root 3. So now we can put it into this equation. So what we have basically, so v2 is equal to, so this time v is equal to v1 root 3 by 2 plus v2, we can replace v1 by root 3 into 2 is there. Sorry, v1 by root 3 and half is there. So from here, v is equal to, you can take v1 by 2 common, and you can just, so this thing is there, yes. So v1 by 2 you can take common, and root 3 plus, this is v1, and 1 by root 3. And so we can just go for v1 4 by 2 into root 3. So you have to do this calculation very slowly actually. So v1 is equal to So we have to just check V1 is equal to 2 by, sorry, root 3 by 2 into V. So this option is again correct one. So it is given V1 is equal to root 3 by 2V, and this option is correct. Now, if we can calculate V1, we can easily calculate V2. So V2 is equal to root 3 by 2 into, uh, sorry, the V1 is root 3 by 2 V upon root 3. So V2 is equal to V upon 2. And what will be kinetic energy of second particle? The kinetic energy of second particle is half m. This is for second particle, V upon 2 whole square. So this is half mv square by 4. And what is your total kinetic energy? So here total kinetic energy is also conserved because the collision is elastic. So if total kinetic energy is going to conserve, so total kinetic energy initial is T, that value is equal to half mv square, and T2 is just written as T by 4, that will be 25% of T. So we have to calculate each and every point in a mathematical form. Then only we can correct the MSQ. And yes, you have to know the basic concept of the problem. And only one this problem can make your concept beautiful about the collision problem. But yes, in this problem, the beauty is that this particle is rest. So this is a very nice problem. And so you can just check whether what will be your answer. So first is that relative angle with 90 degree. The speed of particle P1 is root 3 by 2V, and the kinetic energy of second particle is basically 25% of total energy. And the kinetic energy of center of mass is not going to change. So this is my option. Thank you.